Hello, dear students. Welcome back to my YouTube channel. Good evening, Bida. Good evening, Ria. Okay, I guess I am audible and visible to you. I hope I am audible and visible to you now, right? Okay. Up to now, we have completed 4 lectures of NLM, and we have completed a lot of topics like first law, second law, third law, inertia, momentum, rocket propulsion, friction, no, not friction, contact force in horizontal, contact force in a body's contact, right? Weight, tension in a uniform rod. These cases we had discussed it lastly. Now in this session we will be starting constrained motion, then spring force. So this NLM will take one more lecture. That means today, this lecture and lecture 6. So I hope we will complete the NLM within the 6 lectures. Okay. So from Monday, we will start circular motion if possible. Because today I am busy with my cousin's wedding. So I will be busy, right? I don't have time to just create any things on YouTube. So I will be busy with the celebration. But from Monday I'm free. I will be taking 2 classes per day as per schedule, and I will complete the topics on Monday, most probably. Okay? Shall we start now? Okay, I have not given you the monkey problem. Okay, so today what we will do now? We will do 2 monkey problems. Okay, today we will do 2 monkey problems. Then we will start the constant motion. No worries, now we will do 2 monkey problems. There is no issue. Okay, and monkey problem is not that big deal. Okay, it is only monkey is going up or monkey is going down. If monkey is going up, so you will take tangent as major dominant one. If monkey is going down, you will take MG as dominant one. It is not that difficult, but still, if you want, I will just teach you. No issue. Now my screen is visible. Now let us start with the two monkey problem. The best way to be the PPT, right? But I don't have that much of time to create PPTs on all these things. So that's why sometimes I forget to take some topic, okay? But those are not a major topics. Let us write a numerical. Numerical first. A monkey of mass 20 kilogram is climbing on a rope. Climbing on a rope. If, right, you will just do one thing now, refresh it once, everything will get sorted. Breaking strength, if break of rope is 250 Newton, find maximum acceleration, with which monkey can climb on. This is my problem, okay? And we need to do this problem. 1 second. Okay. How to do it? First of all, so let us make a diagram of it. We are having a rope, and on the rope there is a monkey. It's my monkey, and monkey needs to go up. Monkey want to go up. So what you will write now? Look, When monkey is climbing up, so tension will be upwards because mg of this person will be downwards, the monkey will be downwards. Right equation, I guess T minus mg is equals to m into a. This is my equation. So if my tension is maximum, let us suppose I will write m into g. M is fixed, so A will be maximum. What is maximum tension? Is it 250 Newton? 250 minus what is m? G, it is 200. 200 equals to MA. MA, A max. So I will write A max equals to 250 minus 200 divided by 20. My answer is 50 by 20. My answer is 2.5 meter per second square. Easy? Easy or super easy? Easy or super easy? Super easy, no? Numerical. Numerical. Now we are having a string. We are having a string. On this string, monkey is like this. Monkey is like this, right? Done. If maximum tension is mg by, that means my braking strength. If the braking strength of this rope is mg by 2, so find acceleration with which your monkey can climb down or go down. Look, now one thing, tension will be always upwards, no? Mg will be downwards. Which will be dominant, mg or t? If it is going downwards with acceleration a, so mg will be dominant. I can write mg minus t equals to m into a. Okay, mg, what is t? T is mg by 2 equals to m into a. I can write here mg by 2 equals to m into a. Therefore, my acceleration came out to be g by 2. My acceleration came out to be g by 2. This one, easy or super easy? These are monkey problems. These are monkey problems. Easy? This one also, na, super easy. So now we are done with monkey problems. Is there any other numerical property you want to consider? I think from my end, na, everything is covered now. I guess for me, everything is covered now. Okay, do one thing, na, do one thing. Search for more numericals. Search for more properties, right? If you have more things to be done after doing your own homework, then you can let me know in the next class. There is no issue. And I will make sure that I will teach those things as well. Okay, don't worry. Now let us start new topic, and this new topic is known as string constraint motion. String constraint motion. String constraint motion. Okay, string means the rope. Okay, constraint motion means it is a motion which is fixed. Just like you have seen the horses, right? The horses, when the horses are pulling the cart, they have the eye folded like this, no? They have some sort of leather things like this, right? Why? Because their motion is constrained. They only will go along this way. Constrained motion means the way of going the object is fixed. That is constrained motion. Okay, and along the constrained motion, velocity will be always same. I will give the examples to get a better understanding of what constrained motion is all about. So this is my look now, and we are having a box on it. Done. We're having one more box here. I will tell you what constrained motion is. One of the simplest topic that you can come over. My pulley. Okay. Mass of object is m. This angle is theta. My this velocity is v naught. Now I need to find out this velocity. Find this velocity. Find this velocity. If you find something like this now, so just click on it. It is a case of constrained motion. Why? Because motion of this box is related to motion of this string. Now you can see now, if the string is getting pulled by v naught, the at every point the speed of this rope will be v naught. That means here is v naught, there will be v naught, v naught, v naught, v naught, v naught. So at every point the speed will be v naught. Look, if this speed is v naught, so what this angle is? If this one is theta, this will be 90 minus theta. This will be 90 minus theta. Done? If this one is v, what will be this component? Sir, the component along v naught will be v cos 90 minus theta. It is v cos 90 minus theta is sin theta. That means one more velocity will be there, and that is v sin theta. Now look, v sin theta is same as that v naught. So I can write here, sir, v sin theta is same as v naught. So my v came out to be v naught sin theta. Easy or super easy? Easy or super easy? Easy or super easy? Huh? Easy or super easy? Do one thing now. Go with the rope. Go with the rope. Only thing you need to note down, that is go with the rope. If the speed of rope is v, at every point its speed will be v only. Then you have to take the component. You have to take the component of velocity across the rope. No, you have to take the component of velocity along the rope. Only 2 points. Take speed of rope equal at every point. Second one, take the component of the body along the rope. Only these. Look beta. Look beta. Having a rope like this now, its speed was v naught. One more is v here. V is here, right? This angle is 90 minus theta. 90 minus theta. So one thing is there now. Look, if this is v, so what this component will be? Sir, this component will be v cos 90 minus theta. V cos 90 minus theta. Now v cos 90 minus theta, it is the speed of this rope, but it is already v naught now. So I can write v naught is equals to v cos 90 minus theta. And cos 90 minus theta equals to plus sin theta. So I can write here v naught equals to v sin theta. So v is equals to v naught divided by sin theta. V equals to v naught sin theta. Easy na? Constant motion is not that difficult, right? Okay. If you are done with this thing, now let us do a numerical. Let us do a numerical then. Okay, everything is visualization. If your visualization is good, you can do everything. Okay. Look now. This block is going like this with 10 meters per second speed. Okay. This block is connected here. And these are connected like this, right? Okay. And here is a pulley. They're attached to a pulley. They are attached to a pulley. It is like this, okay? So look now. If this angle is 53 degree, this angle is 60 degree, take this speed as v. We have to find out this v. We need to find out this v. Okay, look, we can take the same component now. V, it is v cos 53 degree, we will get it. But for that thing, we should be aware now that we need the value of speed of this rope. We don't know. What we can do now, we will extend it. Just extend it. Just extend it. Look now. If this angle is 60, so this could be 60 as well. If this one is 10, so this will be 10 cos 60 degree. 10 cos 60 is 1 by 2. Answer is 5 meter per second. So here will be 5 meter per second, 5 meter per second, 5 meter per second, 5 meter per second. So this speed is 5 meter per second. So this will be here now. It is v cos 53 degree equals to 5 meter per second. Done. V cos 53 will be 3 by 5 equals to 5. V equals to 25 by 3 meter per second. 25 by 3 meter per second. Is it easy? Easy or super easy? Beta, easy or super easy? You should be aware, no? How we can do these numericals. Easy, not super easy. Okay, no worries. Let's take one more example. Let's take one more example. It takes time, na, to get fit into the mind. It takes time. It takes time. I am making the diagram very clear now so that you will have better things. This one is going with V naught. This one is going with V naught. Okay. Mass is M. Mass is M. If this velocity is Vy, going, look, if we are just stretching it now, it will go upwards if this velocity is Vy. And look now, if this angle is theta, this angle is theta, find Vy. Find Vy. How to do Vy? Look, if this is Vy, so one will be here, Vy cos theta. In the same way, this will be Vy cos theta. But Vy cos theta is V naught, so I can write Vy cos theta equals to V naught. Done. Second one, Vy cos theta equals to V naught. So what is Vy now in both the cases? So sir, Vy equals to V naught by cos theta. It is V naught cos theta. Okay. Easy. Okay. One more problem. This is my rod. Make equal all these diagrams very clear. My pulley. Okay. Look now. If the mass of this box is m, so here we will get mg. It is radius mg. It will go down with speed v naught. So I need to find out the speed of this ring. This ring, right? It is ring. So we know that if this is v, this is theta. So this will be v cos theta. And speed is v naught. So speed is v naught. I can write v naught equals to v cos theta. So v is equals to v naught by cos theta. V equals to v naught by cos theta. Thank you, beta. Gaurav, thank you. Okay, this is how you can do it now. Easy or super easy? Easy or super easy? Okay, one last numerical from this topic, then we will start spring force. We are having a system like this. We are having a system of like this. And we are having a rod. Here we are having a rod, right? It won't be like this. We are having a rod. The rod like this. Okay, there is a rod. Okay, look now, if this angle is theta, what we can do, this one is going with velocity v naught like this. So if this rod is going with velocity v naught, so this end will go with v velocity. How to find this v velocity? How to find this velocity? Look now, if we have rod like this now, if this end is slipping like that, so this will go down, right? It will go like this. So we have to find this v. Again, constant motion. So look now, we can do like this. V naught, this is theta. So this could be v naught cos theta. So here this speed will be how much? V naught cos theta. Okay. Theta, this one is 90. So this one will be 90 minus theta. If here is v, so this component will be v cos 90 minus theta. So it is v sin theta. Done, na? I can write v sin theta. It is equals to v naught cos theta. So v is equals to v naught cos theta divided by sin theta. So v equals to v naught cos theta.
5 minutes. 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 5
Easy or super easy? Easy or super easy? Huh? Easy or super easy? Easy or super easy? This one, no? Now it is my guarantee to you, if you are doing the constant motion questions now, you will do 100% correct now. The only thing you take the component. Okay, now let us start second last force. Second last force. We were having weight. Okay, then normal, then tension, then spring force, then friction. So we are done with three forces. Now let us start spring force. So in this class, we will be doing with spring force. Spring force. So what spring force is all about? So basically, a spring is a helical metallic wire. This linear spring is helical. It is helical. This is helical metallic wire. Helical metallic wire. And it is natural length L naught. L naught means natural length. Natural length. Natural length means when no force is present. If my F is 0. Natural length means if my F is 0. Now second case, look now. This is my natural length. This is my natural length. If somehow we applied forces on both the ends. If somehow we applied the forces on the both ends. So it is length changed by delta L. So L naught plus delta L. So due to this application of force, F external, due to this application of force, this rod or this spring wants to go back to this original position, due to which there will be a force of spring. There will be a force of spring. And force of spring is always opposite to that of external force. Okay? Look, if you are stretching it now, you will do it at your home now. If you are stretching the spring is just pulling you back. The pulling is back means spring force. Why the spring force is there? Because when you are changing the natural length of your spring, a force gets created due to the disturbing of the atoms. If you are disturbing the atoms now, look, atom is like this now at their normal length. Now if you are disturbing now, if you are disturbing like that, right? So the atoms want to go back. Look, you are just pulling them like that now. They want to go back. So this go back position of the atom is known as spring force. That's why spring force is electromagnetic in nature. That's why spring force is electromagnetic in nature. So I will write here, spring force is electromagnetic. Spring force is electromagnetic in nature. Done now. One more case is there. One more case is there. And the case is, look now. If we extend it, the case is, if you now compress it, you want to compress it. That means you applied force external like this. You compress it. Its length becomes N naught minus delta L. Look now. Original position of the atoms. Now you compress it. They want to go to the normal position. So they want to go pull out, right? Like this. So now my force of spring. Now my force of spring will be opposite. This is my force of spring. This is my force of spring, Fs. Done? Why? Because spring force want to get its original position. It is restoring force. Spring force is a restoring force. Done na beta? So there is a one law known as Hooke's law. There is a law known as Hooke's law. Okay? If you are doing small extension, under small extension or compression, under small extension or compression, Done? The spring force is proportional to change in length. So my spring force, if my x is, let us suppose, change in length is x. Suppose na, change in length. Change in length is x or delta L. So my spring force is proportional to the x or delta L. That means my spring force equals to minus k times x. Hooke's law. This law is known as Hooke's law. Okay, if you want to draw a graph of it, look, y equals to mx plus c. Y is f, m is minus k, x is x, c is 0. So if you want to make a graph of it, extension x minus x, force, now it goes with 0 and slope is negative. That means it is like that, no? Theta is more than 90 degree. Okay, this is extension. This one is compression. This one is extension and this one is compression. What is k? K is constant. This k is spring constant. This k is spring constant. This k is spring constant. Okay. Done? Done with this slide? Done with this slide? Done with this slide? Then we can move to the next one. If you are done with this one, then we can move to the next one. Okay, let us move to the next slide and we will be starting a numerical approach now. Oh, so my system, it is given that my system is in equilibrium. If my system is in equilibrium, find extension. Find extension. Find extension. How, sir? Look. This is my system. This is my system with 2 kg mass and K is 1000 Newton per meter. Find X. Find X. Look now. Look now. If 2 kg is there, that means this will be 20 Newton. This will be 20 Newton. Due to this 20 Newton, elongation will be there. To oppose this elongation, there will be a spring force F, and that F will be opposite to that of this one, no? So now, if it is in equilibrium, if this system is in equilibrium, that means my 20 Newton should be equal to Kx. Okay, equilibrium means when my F net equals to 0. So I can write now my Kx equals to 20 Newton. So K is 1000, X equals to 20 Newton. So X came out to be 20 by 1000. Cancel out. It is X came out to be 2 into 10 to the power minus 2 meter or 2 centimeter. 2 meter or 2. Done. Just take, look, the way we were dealing with tension, na, same way deal with this spring force. Same. It is same. One of the same thing, right? It is not something different. Just like you are taking your tension mass below into G. In the same way you have to do like this one. Just look. I will be giving you second numerical. If this is my second numerical, look now. One spring is there. One box is there with mass 1 kilogram. One more spring is there. One more box is there with mass 2 kilogram. Done. Look now. K1 spring first constant is 1000 Newton per meter. K2 is also given as 1000 Newton per meter. Done. Here extension is x1, here extension is x2. I want to find x1 and x2. So what I can do, look now, I will take FBD. 20 Newton is downwards. Here Kx1 is upwards. Here 10 Newton downwards and Kx1 downwards. Done. In the same way here, right? It is Kx2, sorry, Kx2. So there will be Kx1. There will be Kx1. So how to find this Kx1 or Kx2? System is in equilibrium. So what I can write now? Can I write now, sir, Kx2 equals to 20 Newton. So x2 came out to be 20 by x. 20, x is 1000. Is it 2 centimeter? What is this one now? This one now. I can write Kx2 equals to, sorry, Kx1. Is it equals to, here it is Kx2 plus 10. Okay. It is Kx2 plus 10. Kx2 is 20. K is 10. Is it Kx1? So Kx1 came out to be 30. So x1 came out to be 30 divided by 1000. Is it 3 centimeter? Just like I am doing now, you should do it like this. Same. Do like the same. Done. Okay, look now. Super easy, no? Great. Now let us do one more numerical. So we are having two boxes like this. 10 kilogram. It is connected with a spring. Different box. 15 kilogram. We are just pulling it with 60 Newton. We are just pulling it with 60 Newton. And acceleration of 15 kilobox is 2 meters per second square. Okay. So what should be the acceleration of this part? What should be the acceleration of this part? We don't know. We know nothing about this numerical. Okay. Nothing about this numerical. Okay. So how we can do it? If you know nothing, do FBD. Do FBD. First of all. If you are stretching it like this, so there will be a 1/4 that is Kx opposite. So Kx like this. Make FBD now. Is it 10 kg? Is this one Kx? Acceleration is A. One more box. 15 kg. 60 Newton. 2 meter per second square. Kx. Okay. Look, I can write 60 minus Kx equals to mass into acceleration. 60 minus Kx equals to 30. 60 minus 30 equals to K times X. Okay. Is there any value of K is given to us? No. We don't have X. Came out to be 30 Newton now. It is force. Okay. This one now, I can write Kx minus 0 equals to 10 into A. Kx is 30. 10 into A. So A came out to be 3 meter per second square. For me, it was a super easy. Super easy. Only FBD is the key. Create the FBD and get the answer. Create the FBD and get the answer. Clear? Is your super easy? Okay, one more numerical, a good one now. We are having a system like this. $20 kilogram. 30 kilogram. What will happen to this structure if it is a steady state? Look now, 20 Newton is there. This will be 200 Newton. There will be Kx. If K is 24, there will be Kx. There will be K. Kx is same, na? It will be Kx here. Just like tension. Okay? Here, 300 Newton downwards. Normal reaction upwards. What is acceleration? It is net force divided by total mass. Net force is 200 Newton. Mass is 50. It is 4 meter per second square. 4 meter per second square. Now take FBD. Do FBD now. Okay. Look, I will take 30 kilogram box. 30 kilogram. This one is Kx. I can write Kx minus 0 equals to mass into acceleration is 4. Kx is equals to 120. So x came out to be 120 divided by 24. X came out to be 5 centimeter. Easy or super easy? Easy or super easy? Easy, super easy? Huh? Easy or super easy? Okay. Look now. One more numerical, and this was a PYQ also. One box, 2 kg mass. String with tension T. One more mass, 3 kilogram. Okay. So we cut it. We cut this one. We cut this one. From here, now we cut it. After cut, find the acceleration. Acceleration of 2 kilogram box and acceleration of 3 kilogram box. Now before cut, now what happened before cut? Before cut, there will be a 30 Newton force downwards. Here tension upwards. Here 20 Newton downwards. Tension downwards. There will be a Kx. Okay, this Kx. And this Kx will be 20 Newton plus 30 Newton. It was a 50 Newton. Before Kx. Sorry, before cutting. Now you cut it. Now you cut it. We have a box like this now. You cut it now. It is 3 kg box now. Now you cut it. So there is no tension. So tension is 0. But still it will go down with 330 Newton now. Acceleration is downwards. So what is answer now? What is the answer? Sir, F equals to mass into acceleration. Force is 30 Newton. It is 3. I have mass, right? So acceleration came out to be 10 meter per second square. Downwards. Now, if you talk about this one now. 2 kg now, 2 kg. Now you cut it from this particular point. At that particular end, we have one force Kx upside now. And Kx is still 50 Newton. We know it. But below, there is only 20 Newton. Because this T is 0, T is 0. But still upside now, it is 15 Newton at that particular extent of time. It is at cutting time, right? Just after, it's not after long time. Just after. It will go back now. You cut now, this spring will get it back. So spring is having 50 Newton. So now I can write 50 minus 20 equals to mass into acceleration. It is 30. Mass is 2 into acceleration. So acceleration came out to be 30 divided by 2. Okay, that means 15 meter per second square. It will go upwards. This will go downwards. This one, easy or super easy? Easy or super easy? Easy or super easy? Okay. Now let us cut it from upper side. Now we are having a numerical. We have a numerical like this. We have a numerical like this. This is my numerical. 2 kg, 4 kg. These are my things given to us, right? Now, if we cut it from this end, here we cut it. Just after the cutting, what will happen to the system? Look now. Before cutting now, look, 20 Newton is downwards. Okay, here, one spring, let us suppose it is kx2. It is kx2. Here, first of all, kx2 will be there. Second thing, 40 Newton is there. Here, it is kx1. It is kx1. Okay, and kx1 will be equals to 40 plus kx2. Now, if you cut it down, what will happen now? If you cut it down, what will happen now? Look, if we will take 4 kg box, it is 4 kg box. Okay, look, now it was kx1. Now when you cut it down, this kx1 becomes 0. This kx1 becomes 0. But still, here we are having kx2 now. We are having kx2. We are having kx2. Done? We are having this kx2, and this kx2 is equal to 20 Newton. And this kx2 equal to 20 Newton. Do you know why? Look, when you cut down the upper end, this system will go downwards like this. It will go like this now. That means there won't be any kind of compression or elongation of second spring at that moment. There won't be any compression or any kind of suppression at that moment. So my 40 Newton is always there. 40 Newton. So what will be the acceleration of 4 kg block? Acceleration. Net force. What is net force? Sir, it is 40 Newton plus kx2. Kx2 is 20 Newton. Total mass is 4. It is 60 by 4. Done? Per second square. Now, if you talk about 2 kg box now. For 2 kg box, we are having kx2 upwards. We are having 220 Newton downwards. Acceleration of 2 kg box. Net force. What is the force? It is kx2. 20 Newton. And kx2 is 20 Newton. Equilibrium position at the end now. I can write it is 20 Newton minus 20 Newton divided by mass is 22. Sorry, the acceleration is 0. So the acceleration of second part will be 0. Acceleration of second part will be 0, but at that particular end. That means, look, this is my below box, upper box. Okay. When you cut down the upper one, so what will happen now? This system won't get like that now. It won't get like this. So that first of all, the upper one comes down a little bit. The upper one will come down a little bit. When it will come down, then after that this will go down. Okay. When you cut down it now, the upper one will come down like little bit, then this will go down. It is not like you will cut the thread, both will go down. Not. It is not that way. Wait. Why? Because the acceleration part of comes to top is 0. That means this one is at rest at that particular instant of time, but the acceleration upper one is 60 by 4. So it will come down like that, then it will go down. Done, beta? Any confusion to this numerical? Done now? Done? Okay. Now let us start spring balance. Let us talk about spring balance. Spring balance. What is spring balance? Spring balance is an instrument that measures tension in a string. Spring balance is an instrument that measures tension in a string. Okay, so you have seen now, you have seen this instrument. Instrument looks like this. It is the second weighing machine, right? Second. It looks like this. Okay, then we are just hooking a mass here, so it is given as a reading. This is also given as the reading of weight, right? Just like a reading. Most important thing of spring balance is reading, and reading is tension by G, kilogram weight. Kilogram weight is the unit of reading. Unit of reading. Okay. So here spring balance is the measure of tension. Spring balance is the of tension. Let us do a one numerical to get a very better understanding of it. If we are having an inclined plane like this with the inclination of 30 degree, so here we are having an instrument, spring balance. This is my 10 kg box. It is connected with a spring balance. It is connected with a spring balance thing. Done? Find tension. Find tension. Look now. Look now. If it is 30, so this force will be mg sine 30 degree. There will be a tension T. Done? Tension T. M is 10. G is 10. Sine 30 is how much? 1 by 2. 2 ones are 2. 2 fives are 10. It came out to be 50 Newton. 50 Newton. So my tension came out to be 50 Newton. What is reading? It is T. T is 50 Newton. G is 10. So my answer is 5 kilogram weight. My answer is 5 kilogram weight. Easy or super easy? Easy or super easy? Easy or super easy? I will take this example. If it's okay, if this one is, let us suppose 10 kg. 10 kg. There will be a tension T. There will be a 100 Newton. Okay. So tension came out to be 100 Newton. Reading is equals to reading in tension by G. It will be 10 kilogram weight. 10 kilogram weight. Easy or super easy? Easy. Huh? Okay, let us do more examples. More examples. With the connection of pulley. Here is my spring balance. Now you will come to know the importance of thrust or repulsive force. Okay, there is my pulley. It is hung up like this, right? There are two masses. 10 kilogram. 10 kilogram. Okay, so look now, if it is 10, this will be 100 Newton. This will be 100 Newton. This will be tension T. This will be tension T. Tension T. Tension T. This repulsive will be 2 times tension T. Done? So what is reading now? What is reading now? What is reading now? Reading is tension divided by G. It is tension divided by G. What is tension? Is it 2T? I can write 2T divided by G is 10. What is 2? 2 is 2, 10 is 10. What is T? Look, T is 100 Newton. I can write here 100 Newton. Cancel out, so my reading came out to be 20 kilogram weight. 20 kilogram weight. Easy or super easy? Easy or super easy? Huh? Easy or super easy? Okay. We're having now one case is parallel connection. Look, here we are having spring. This is my spring. Done. Hook. One more spring. Hook now. Hook now. 20 kilogram. Constant K, constant K. Spring 1, spring 2. What will be there? Look now. If it is 20 now, so 200 Newton will be downwards. There is tension T. There will be a same tension T. Same tension T throughout. I can write came out to be 200 Newton. Tension came out to be 200 Newton. So I will write here divided in Newton divided by 10. It came out to be 20 kilogram weight. 20 kilogram weight. In second case, if we are having something like that, something, two springs now parallel to each other. If we are having two springs parallel to each other like this, 20 kilogram, what will happen? 200 Newton downwards. Tension T, tension T, TT 2T. So I can write 2T. 2T is equals to 200 Newton. So T is equals to 100 Newton. Okay, so reading is T by G. It is 10 kilogram weight. This one is my parallel case. In parallel case, reading decreases. In series case, reading remains same. In parallel case, reading decreases. In series case, it means easy or super easy? Easy or super easy? Huh? Easy, super easy. Done now? Okay. If we have different numerical, now, that is, we are having a spring like this now. Spring like that, right? Okay. Box. Pull it with 20 Newton. Pull it this one with 10 Newton. Find 10. Find reading. Find reading. How you will do now? First of all, this case will acceleration. This 20 minus 10, 10. That means 10 by 10, 1 meter per second. Take anyone, now. Take anyone. Take like that, right? Make equation of it. How do you write? 20 T equals to mass is x 1. So tension came out to be 20 minus 6. Tension came out 14 Newton. It is 14 Newton. So reading is equals to tension by G. It is 1.4 kilogram weight. Look, in this there will be elongation of it. After elongation, there will be a dragging of your spring. After elongation, there will be a dragging of the spring. If there is dragging, there will be acceleration also. Okay, dragging, there will be an acceleration also. So you will get it now. Easy or super easy? Easy or super easy? Huh? Easy or super easy? Okay, so let us start now. New topic. What is time now? We have time now. We have our own time, right? Let's start. Frame of reference. Frame of reference. Frame of reference. Okay, what is frame of reference? Where from your observer is seeing all your things, that is the frame of reference. I discussed the frame of reference in detail in first class. Done. We are having two frame of references. Two. First one is inertial frames. Inertial frame of reference. Second, non-inertial frame of reference. Non-inertial frame of reference. Non-inertial frame of reference. In inertial frame of reference, my acceleration of frame is 0. Okay, that means frame is at rest or moving with constant velocity. Done. In this case, laws of motion are applicable. Laws of motion are applicable. But if we talk about the non-inertial frame, my frame is accelerating. So you can write here, my frame is accelerating. My frame is accelerating. If my frame is accelerating, so you cannot apply. You cannot apply laws of motion. Apply laws of motion. But if you want to apply now laws of motion, if you want to apply, you need to consider an imaginary force. Imaginary force. And that imaginary force is known as pseudo force. That imaginary force is known as pseudo force. So what is pseudo force? Pseudo force is a considering imaginary force with the help of which we can apply the laws of motion in non-inertial frame. Done. And my pseudo force, F pseudo is mass, the thing you are observing, into acceleration of observer. It is acceleration of observer. Acceleration of observer. Done. And this will be opposite to that of your, look, if I am the observer, I am getting like this, right? I am sitting inside the lift. Lift is accelerating upwards. The force will be downwards. Pseudo force will be downward. Let us take an example to understand pseudo force. If we are having a lift case, if we are, okay, observer is standing here. So and it is going with acceleration A upwards. Here is a weighing machine, something like that. No? On this, we are having mass M. Clear now? Look now. What do you write? Sir, mg is downwards. Normal is upwards. So what you will write here? Okay, you will write n minus mg equals to m into a. So n came out to be mg plus a. You will write it now. It is correct, but it is correct for this one now. Now, if a person is here, now this person is going with acceleration a. So according to this person, it is an non-inertial frame. Now for this person, it is a non-inertial frame. look, we are not considering pseudo force. Now for this person, what will be the equation? The person will write n equals to mg. For this person, the person will write n equals to mg. But the real answer is n equals to mg plus a. So the answer is wrong. Okay. So if the body is going upwards, so there is accelerating frame. So there will be a what? There will be a pseudo force m into a up down. Now you need to write the equation. Now for this person, he will write n equals to mg plus ma. That means it is mg plus a. Now you will write this equation is correct, matching with this equation. This is the main reason why we are taking what? A pseudo force into consideration. No? Why we are taking this pseudo force into consideration? It is the main reason. Okay, take 1 minute time, analyze the whole thing. Why there is pseudo force? Why there should be a pseudo force? Then we will start one. Right? Done now? Easy. Why is it lagging? Easy, beta. I get that. I'm also experiencing the lag. Okay, let's take an example. Look, we are having a car, my big car. Okay, this car is rolling. It is going with the acceleration a right this way. Here we are having a bob. Initial condition of bob. After some time, bob will go there, right? Bob will be there, right? It is making angle theta. Write the equation for the bob. How do you write the equation? First of all, sir, mg, if the observer is here now, look, mg will be downwards. If it is going rightwards, leftwards will be my pseudo force. There will be my tension. This will be my t cos theta. And this will be my t sin theta. Write equations. Sir, my t sin theta equals to m into a. My t cos theta equals to mg. Take the ratio of it. So my tan theta is equals to a by g. So theta is equals to tan inverse a by g. Tan inverse a by g. Done? Done? Second thing, we need to find tension. How to find tension? Look now. Take first equation and square it. T square sin square theta equals to m square a square. Take second equation and square it. T square cos square theta m square g square. Add both the equations. T square sin square theta plus t square cos square theta equals to m square a square plus m square g square. Look now, t square. Internal we are having sin square theta plus cos square theta. Then m square is common. It is a square plus g square. Okay, t square. Sin square theta cos square theta is 1 equals to m square. Then it is a square plus g square. So t came out to be under root of m square a square plus g square. So t came out to be m under root of a square plus g square. Done? Easy or super easy? Easy or super easy? If you want to write from ground frame, look, if a person is sitting here now, so from ground frame, what the person will write? The person will write t sin theta minus 0 equals to m into a, and t cos theta equals to mg. Both equation came out to be same, right? Both equation came out to be same. Easy or super easy? Easy or super easy? How beta? Super easy. Okay. Now we are having two most important formulas of physics, and that is, look now, if we are having an inclined surface, if this is my inclined surface, on this inclined surface we are having a body. We are having a body. We are having a, what happens to it now? No worries. Look, here we are having a body. Mass of body is m. Okay. Observer is sitting here, right? And this wedge is going with acceleration a. This acceleration is going, it is going with acceleration a. 1 second, beta. Not to lag. 1 second. One second. Okay. It is going with acceleration a. So what we have to find out, what should be the value of this acceleration so that this box remains rest. It remains at rest with respect to wedge. Okay. Okay. Write down the equations firstly. This angle is theta. So I have, this one is mg, theta, mg cos theta, mg sin theta, normal reaction force, pseudo force, theta theta, ma cos theta, ma sin theta. These are the forces of it. Now, these are the forces. Now, what we have to find out, what should be the acceleration for that the wedge should remain at, this bucket should remain at rest with respect to the wedge. So if this should be at rest, so this force should be equal to this force. Yes, sir. So ma cos theta should be equal to mg sin theta. Cancel out. Cancel out. So a came out to be g sin theta by cos theta. So a came out to be g tan theta. If the acceleration of this wedge is a and it is equal to g tan theta, so my this block will be at rest. So what will be normal reaction force? So my normal reaction force is mg cos theta plus ma sin theta. Done. So I can write mg cos theta plus m. What is a? A is g tan theta. Tan theta is sin theta by cos theta equals to sin theta. So I will take mg common. So it is cos square theta plus sin square theta plus cos theta. It came out to be my normal reaction force N equals to mg into 1 divided by cos theta. It came out to be mg sec theta. Mg sec theta. Done, beta? Easy or very easy? Or super easy? Easy, no? Easy? Okay, one more case. One more case, beta. Look. This is my wedge. My block is there with mass m. Now it is going with acceleration a. it is going now with acceleration a. If this body should be under free fall, if this body should be under free fall, what will be the value of this acceleration? So if you know, beta ji, look, I didn't know the values, na. I don't know nothing the values. But what I do, na, I knew if I am writing like this, na, how to find like that. I know the basics. I don't know the equations. I don't know m is sec theta. If tomorrow you will ask me, sir, what will be that thing, na? So I need to derive these things. It will take 1 minute, not more than 1 minute to derive all these things. You should know, okay, what should be the acceleration's value so that my block should remain rest. What is acceleration? A g tan theta. You should know how to derive these things, the basic of it. Now, this one now, under free fall. Look now, I will firstly mark the forces. If it is going along this way, so my pseudo force will be ma. Okay, there will be a normal reaction force. Done. This will be mg. This will be mg cos theta. Suppose, no? This will be mg sin theta. We know these things. Look now, look better. If free fall means my normal is 0. Free fall means under free fall, my normal will be 0. Under free fall, my normal will be 0. Done? Look, it is mg cos theta and it will be ma sin theta. Ma sin theta. So my normal is equal to mg cos theta plus ma sin theta. Done. So I can write mg cos theta in a magnitude equals to ma sin theta. Cancel out. So a came out to be g cot theta. Normal is 0. Acceleration is g cot theta. Done. Easy or super easy? Easy now? Beta? Okay. Tell me for this one now. If we are having a pulley, this mass is m2, this mass is m1. This is my pulley, right? Tension will be T. Done. And m1 is more than m2. Suppose. So what you will write? Sir, this will be m1g. Sir, this will be m2g. This will be downward acceleration, upward acceleration. So how to write the forces now? Look, I can write acceleration is F net. F net divided by mass. F net m1g minus m2g divided by 1 plus m2. So I will write m1 minus m2 divided by m1 plus m2 into g. I can write like that. Now how to find tension? What is tension T? Okay, we know that it is 2 times m1 m2 divided by m1 plus m2 into g. We know these things now. From the previous couple of lectures, we are discussing these things now. We are discussing these things. Done? But what if system is in the lift? What if the whole system is under the lift and the lift is going upwards with acceleration a naught? With acceleration a naught, then there g becomes g effective. G becomes g effective. Acceleration came out to be m1 minus m2 into g plus a, or a naught divided by m1 plus m2. My tension came out to be 2 m1 m2 m1 plus m2 g plus a. Okay, sir, how to write g plus a? Just remember the lift case, the apparent case. Done. Done now. Okay, one more numerical. One more numerical. If we are having a cart or car, this is my car. Here is a person. There is a one mass of m1, one more mass of m2. Both are connected with a string. Both are connected with the string. So what you need to find out? What you have to find out? Find the acceleration so that m1, m2 remains at rest. First of all, m2, there will be a m2g. There will be a normal reaction force. There will be a pseudo force m2a. There will be a pseudo force m1a. There will be a tension T, normal m1g and normal. These things we know. I can write m1a equals to tension T, or this tension T is also equals to m2g. Okay, so I can write m1a equals to m2g. So A came out to be m2g divided by m1. Done? Done? So now if we are pushing it by force F, what should be the value of force? So force will be equals to mass into acceleration. Force, mass is mass of, if the mass of the whole thing is m3, so it will be m1 plus m2 plus m3 into A. What is A? A is m2 divided by m1 into g. Is it like that? Easy or way more than easy? Easy or way more than that easy? Huh? Easy? Easy beta? Easy or super easy? Easy? Okay, now last topic. We are having a Lami's theorem. Last topic of class. Bear with me. It is Lami's theorem. There will be a Lami's theorem. Lami's theorem is for concurrent forces. If we are having concurrent, coplanar, it is coplanar, right? P-L-A-N-A, coplanar. Majorly for three forces. If they are at equilibrium means if my F net is equals to 0. So look now, if one force is there, if this is my force 1, this is my force 2, this one is force 3, alpha, beta, gamma, I can write F1, opposite angle is sine alpha, equals to F2, opposite angle is sine beta, F3, opposite angle is sine gamma. This is my equation. You have two ways to solve a numerical. One way is to just do the component formulas and take the balanced things. Second one, take the Lami's theorem. In both the things, you will get your answer done. Suppose we are having a numerical. Suppose beta. Suppose we are having something like that. Now suppose 30 Newton. Tension is T. Bugs is there with 40 kilogram. Suppose 40 kilogram. What will happen now? What do you need to find out? Find tension. Look, if this angle is theta, find this theta also. Okay, so look now. Theta, this is theta. This is 90 degree. This one is 90 degree. Okay, and look, this one now, it is 180. I can add 180 minus theta. Now we are having three forces. It is T, 30 Newton, 40 kilogram. 40 Newton. Take Lami's theorem. I will write Lami's theorem. Look, T sine 90. So T divided by sine 90 equals to, now it is 30 degree, no? I can write here 30 Newton divided by sine 90 plus theta. 90 plus theta. Fourth, it is 40. It is 400. I will take 4 gram now. So it is 4 kg. So it is 40 Newton divided by sine 180 minus theta. Done? So I can write T sine 90 is 1 equals 30. Sine 90 plus theta, it is cos theta, equals to 40. Sine 100 minus theta, it is sine theta. Clear now? Look now. Can I write here now? Can I write here now? These, I will take these two now. Look, I can write 30 divided by cos theta equals to 40 divided by sine theta. I can write sine theta divided by cos theta came out to be 40 by 3, 30. It is 4 by 3. So my theta came out to be 53 degree. Take these two now. It is T divided by 1 equals to 30 divided by cos 53 degree. T divided by 30. What is cos 53? Cos 53 is 3 by 5. So T equals to 30 divided by 1 into 5 by 3. Done now? 3 ones are 3 0. My answer is 50 Newton. Easy or very easy? Easy or super easy? हाँ बेटा, easy or super easy? Easy or super easy? Easy? Easy no? Okay. One more numerical. If my system is like this now, look. If my system is like this, look now. This is my system. There is a spring. Spring is connected like this. There will be a weight 20 kilogram. Angle is 37 degree. This angle is 53 degree. Clear? Here will be Kx. There will be tension. So what I can write now? If the extension x is equals to 4 centimeter, x is 4 centimeter, write each and everything. Look now, 37, 53, this will be 90 then. Look, 90. If 37, 50, it is 90, so this will be 37. This will be 53. Write equations. There will be 200 Newton. Okay, I can write 200 divided by sine 90 equals to Kx. This is 90 now. 90. Kx divided by sine 90 plus 53 degree. 200 sine 90 is 1. Kx. X is 4 into 10 to the power minus 2 divided by sine 90 plus theta. Sine 90 plus theta is cos theta. So I can write cos 53 degree. Okay. It is 200 cos 53. Cos 53 means it is 3 by 5. Whole divided by 4 10 to the power minus 2 equals to K. So my K came out to be 4 on 4, 4 5 20, 0 0, 5 on 5, 5 10 is 50, it is 30, 2, it will be 3000 Newton per meter. It is 3000 meter per meter. 3000 Newton per meter. Okay. Clear? One last numerical. Last numerical, beta. We are having a rod like this. Circle is there. Look now. Tension is T, theta. Okay. How to do it now? Look, if it is T, this is theta. This could be T cos theta. There will be a normal reaction force now along this. There will be a normal reaction force R. So this could be T sin theta. And this will be weight. Weight is W. Look now. If it is at rest, If it is a rest, I can write R vector plus tension vector plus W vector is equal to 0. Done. So look now, but what is T sine theta? T sine theta is R and T cos theta is W. Take square of both of them. I can write T square sine square theta equals to R square. I can take T square cos square theta equals to W square. Just add these things. T square sine square theta plus T square cos square theta equals to R square plus W square. I can take T square sine square theta plus cos square theta came out to be R square by omega square, or T square equals to R square plus W square. It's a P by Q. Easy or super easy? Easy or super easy? Huh? Easy or super easy? Easy or super easy? I want the answer from your end. Is it easy or super easy? Easy. Now we are done with all these topics. Now what I will be starting now? I will start friction. Only one topic is left, that is friction. That is friction. Okay. Friction will be on Monday. Friction will be on Monday. Okay. Then Tuesday. Tuesday I will start circular motion. I will start circular motion. Done? Done, beta? 2 days I kept off due to this marriage ceremony at my home, right? So I won't be able to take any classes. So what do you need to do in the classes? Revise the notes, revise each and everything. Okay, I will upload these notes after friction only. Okay, revise each and everything. Just do your book, then do the PYQs. Okay, and thank you, beta. Thank you very much from your side. Thank you. Thank you very much. Bye. Take care, beta. Good night. Good night. Good night. Good night. Thank you. Okay. Thank you. Bye. Take care. Good night. Bye.